All right, everybody, these are the 2.5 notes where we're going to talk about the quadratic formula. So hopefully you've seen the quadratic formula, but if you have not, then the quadratic formula is this. X equals the opposite of b, so negative b, plus or minus the square root of, and then we have b squared minus 4 times a times c, and then all of it is divided by 2a. All right, so this is our quadratic formula, and that's basically what we're going to be using for today. So what form does our quadratic equation need to be in if we are solving using the quadratic formula? It has to be standard form, and you need to make sure it's set equal to 0. So standard form, set equal to 0. So solve the quadratic equation by using the quadratic formula. Well, the quadratic formula utilizes a, b, and c, so it could be helpful to label these things. So when we're writing this out, we're going to say x is equal to, and then the opposite of b, so in this case negative 5, plus or minus the square root of b squared, which would be 5 squared, minus 4 times a, when there's no value here. Remember that it's always going to be 1, so 4 times a times c, and then all of this is divided by 2 times a. Once you have the formula memorized, it's all about just plugging it in, and then the rest of this question is just doing algebra to make sure that you get the right answer. So here we would say x is equal to negative 5 plus or minus square root of b squared would be 25, 4 times 1 times 4 negative would be negative 16, and then that's divided by 2. All right, so now we can simplify inside of that square root. So we have negative 5 plus or minus 25 minus 16. That would be the square root of 9 over 2. Again, simplifying some more. So we have negative 5 plus or minus 3 over 2. And now we can actually break this one up because we came out of that square root. So it's going to be x is equal to negative 5 plus 3 over 2, and we're going to have x is equal to negative 5 minus 3 over 2. So that would give us x is equal to negative 5 plus 3 would be negative 2 over 2, which is negative 1. And on the other side, we would have x is equal to negative 8 over 2, which tells us that x is equal to negative 4. So then these two solutions would be our answers, okay? And just like when we're solving with factoring or solving by completing the squares, these are called solutions, they're called zeros, they're called roots, and lastly, they are the x-intercepts. So if you don't remember that, that's the same thing for all types of solving when we're dealing with quadratic equations. So let's take a look at number 2. Number 2 this time is not quite set in standard form, okay? But if we would just move this 2x squared to the other side, now we're going to be set equal to 0 and in standard form. So 2x squared minus 2x plus 3. Now we can use that quadratic formula. So we're going to say x is equal to, and then the opposite of b, so this time b is negative 2, so we're going to go positive 2, plus or minus the square root of, and then we're going to have b squared. So this is where we need to be careful. We need to make sure we put the negative 2 in parentheses, okay? You don't want to just square negative 2. You want to square parentheses negative 2. And then you're going to go minus 4 times a, which is 2, times c, which is 3. And then it's all going to be divided by 2 times a. And then again, we're back to a lot of simplifying. So 2 plus or minus negative 2 squared gives us 4. 4 times 2 is 8, times 3 is 24, so negative 24. All of that is divided by 4, which is going to take us to 2 plus or minus the square root of negative 20, and then divided by 4. So it looks like we're going to have to do some simplifying with a radical here. So negative 20, I like to make 3 when it's a negative. Take out the negative 1, because that will give us I. And then 20 would be square root 4, square root 5. Square root 4 would become 2. So now we're going to write this 2 plus or minus 2i radical 5, all divided by 4. And then now I'm going to take this just a little bit further. Okay, so you have options here. You can split it so that you understand the reducing here. So you could go 2 over 4 plus or minus 2i radical 5 over 4, because then that would reduce, because 2 over 4 would be 1/2, plus or minus 2 over 4 here would be 1 and 2, so then we would have I radical 5 over 2. Okay, and then this is a great answer right here. We wouldn't really want to go any further than this because we can't add or subtract an imaginary number from a real number. Okay, or if you want to keep it all as one fraction, you could just reduce all of the values right here. So because 2 comes out of all 3 of these values, we can just reduce it right away and say 1 plus or minus I radical 5 over 2. And whichever way you understand it more, guys, that's the way you should use. But both of these answers are very good for working with quadratic formula. Okay, let's take a look at the next one. So again, next one's not quite in standard form, so we're going to set it into standard form. I'm going to subtract the 12x and add the 5, so subtract 12x and add 5. That gives us 0 is equal to 2x squared minus 12x plus 18. All right, so we are here, and then now we just need to set this into our quadratic formula. So then we're going to have x is equal to the opposite of b, so in this case 12, plus or minus the square root of b squared, which would be negative 12 squared, minus 4 times a times c, all of this divided by 2 times a. And then again, always after this, guys, it's just a ton of simplifying. So what the quadratic formula is really used for here, guys, is just a faster way to really solve a quadratic without having to necessarily complete the square. So we have 4 times 2 times 18, which would give us negative 144. And then that's divided by 4. So that's 12 plus or minus the square root of 0 all over 4. So this one is actually going to be a pretty unique answer where we have the square root of 0, which is just 0. So we're going to say this is equal to 12 plus or minus 0 over 4. Well, plus and minus 0 is really just doing nothing for us, so it's really just 12 over 4. So then the final answer for this one is just 3. All right, and one more example here. Again, setting this equal to 0, so I'm going to add the 3x squared to the other side, so 3x squared plus 6x minus 10. And that would give us x is equal to the opposite of b plus or minus square root of b squared minus 4 times a times c, all of that divided by 2 times a. So then we're going to get negative 6 plus or minus the square root of 36. That's going to be plus 4 times 3 is 12 times negative 10 plus 120. All over 6. Continuing on with the simplifying, so negative 6 plus or minus the square root of 156 over 6. So I'm imagining 156 has a perfect square that comes out of it. Let's try 16. Nope. 36. Nope. Just 4. Okay, just 4. So square root 4, square root 39. Yeah, I think that's going to be the biggest perfect square. So then square root 4 becomes 2. So now we can simplify this even further. So we have this is equal to negative 6 plus or minus 2 radical 39 all over 6. And then now, however you see fit to simplify this is how you're going to simplify it. I see 2 comes out of all 3 of these. So that would give us 3, 1, and 3. So it's going to be negative 3 plus or minus radical 39 all over 3. Okay. Or if you needed to split it, it would look like this. Negative 3 over 3 plus or minus radical 39 over 3, which in this case it might be kind of nice to split this one because negative 3 over 3 actually simplifies even further to negative 1 plus or minus radical 39 over 3. So that gives us even a nicer answer than the one above it. But again, if you stop here, I'm okay with that. All right. So that's the quadratic formula. And really it's just, like I said, a nice, sometimes quicker way than completing the square to find the x-intercepts or zeros or solutions of a quadratic. So the next thing we're going to take a look at is this thing called the discriminant. Okay, so if we're taking a look at the discriminant exists inside of the square root. It's that b squared minus 4ac. This is the discriminant. And it actually can tell us a lot about a quadratic equation. So there's 3 different answers we can get for the discriminant, and we actually saw all 3 earlier here. So notice the first one, we had a positive value inside of the square root, so it can be positive. Okay. In number 2 here, we had a negative number show up inside of the square root, so the discriminant could be negative. And then the last different one, we had 0 show up in the discriminant. So those are the 3 different types of discriminants that we can get. And then notice all the different types of solutions we got. So the first one here, we had 2 solutions. What were they? They were both real numbers. Okay? And so graph the x-intercepts, right? So you can graph both x-intercepts with the real numbers. So for 2, if it's a negative discriminant, you're still going to get 2 solutions, right? We still got 2 solutions here. We have a plus or minus, so that means 2 solutions. But the type that they are is imaginary. Okay? Well, if we get imaginary solutions, that means we're not going to be able to graph the x-intercepts. And then for the last type where there's 0, you only get 1 solution. The type that it is, it's a real number. Okay, and so what does the graph of this x-intercept looks like? It does graph. We can graph an x-intercept, but there's only 1. Okay, so that one is a bounce. So the 3 different types of graphs that we can have here, oops, I meant to say only 1. So the 3 different types of graphs that we can have here are one where we get 2 solutions. So if we graphed that, it could be a graph opening up or a graph opening down where it crosses twice. For one with no solutions, we could have a graph that's opening up that's above the x-axis, or we could have a graph that's opening down that's below the x-axis. And then finally, the one where we only get 1 solution, that means our graph must bounce right on the x-axis, where the only solution we get is the one time where that graph hits the x-axis, which would be the vertex of the parabola. All right, so that's how we're going to use the discriminant. We're going to use the discriminant to tell us how this graph looks on a coordinate plane, really. So it says find the discriminant and tell the number and types of solutions. So remember, the discriminant is b squared minus 4ac. So we're going to take b, so negative 6, and we're going to square it. We're going to subtract 4a times c. And then again, we're going to have to do some simplifying here. So 36 minus 36. So the discriminant in this case is 0, which tells us the number of solutions is 1. The type of the solution is a real solution. So for the next one, we're going to take negative 6, we're going to square it. We're going to subtract 4 times a times c. This time we have 36 minus 32, which would give us positive 4. So the number of solutions this time is 2 because it's a positive value. Okay, the type of the solution that it is real because, again, it's positive. You would be taking the square root of positive 4. That would give us real solutions. And then for the last one here, we're going to take negative 6. We're going to square it. We're going to say minus 4 times A times C. So it's 36 minus 40, which would give us negative 4. So the number of solutions is still 2, right? Because we have a number in there. It's not just 0. But this time, because it's a negative number, it's going to be, the type of solution is going to be imaginary. And so that's because we're going to take the square root of negative 4 in this problem. And right, that would, the square root of any negative would give us an imaginary number. All right, so it says use your graphing calculator to graph a quick sketch of the equations above. Make sure what you see is accurate for your discriminant. So I'm going to just graph these in Desmos real quick. And so if I would graph these in Desmos, it would give us x squared minus 6x plus 9. So as you can see, we have that 1 point right at 3. Okay, and that's the only spot where we touch the x-axis. So if I'm drawing this, I'm going 3 to the right, and then we're just rough sketch, so it's opening up because it's positive. So for the next equation, we're going to have x squared, and then that's minus 6x, and then plus 8. Okay, so for this blue graph that just graphed, here you can see we cross 2 times at 2 and 4. So we're going to go positive 2, positive 4. And again, it's opening up. So a quick sketch would look something like that. And then lastly, we have x squared minus 6x, and then that's going to be plus 10. All right, and so for this last graph right here, you can see it's opening up, and it's never actually going to cross the x-axis. So it's opening up, never crosses the x-axis. So when we're graphing this, we can just say that vertex is at 1, 2, 3, positive 1, and then it's opening up. Okay, so those would be quick sketches of all 3 of those graphs, and they do match what the discriminant tells us. 1 x-intercept, 2 x-intercepts, no x-intercepts. All right. So I hope this gives you a good idea of the 2.5 notes, quadratic formula, and discriminant. As always, message me on Canvas if you have any questions, guys. Hope you have a great day.